Hi, this is Mrs. Holbrook again with our last lesson on Chapter 4 from our geometry book dealing with triangles. And this last lesson is on isosceles triangles. So we're going to use properties of isosceles triangles. We're going to use properties of equilateral triangles. Now remember, an isosceles triangles is one where at least two sides are congruent. Equilateral triangles have three sides congruent. So that's why they often are paired together, because isosceles just means at least two. So sometimes an equilateral triangle can be described as isosceles. Our new vocabulary to think about, and we've talked about it a little bit during this week, was vertex angle and base angles. Okay, so here they're telling us about isosceles triangles. If two sides of a triangle are congruent, so AB is congruent to BC, or AB and CB, we know that the angles opposite of them, so this line draws to this angle A, this line here draws over to angle C. We know that the angles opposite of them are also congruent, and those angles are called the base angles. The two angles that match are base angles. That means angle B up here at the top is your vertex angle, and that measure will probably be different from these two base angles, unless it's an equilateral triangle. Okay, this is a proof of theorem, and we're not going to get into proofs because we don't do them here, but they're just trying to explain to you that if you know that this side AB is congruent to this middle piece CB, and it's congruent to this piece BD, we have an isosceles triangle based on the definition of having the two sides equal. They also tell us that this little angle up here, BCD, is congruent to this angle here, ACB. Still, based on the definition of an isosceles triangle, we know that angle A down here would have to be congruent to angle D over here. And again, we're not going to read through all of these. If you wanted to slow down and look at that, you could. Okay, and again, they're asking for a two-column proof. If you want to look over it, you're welcome to. But basically, as long as you understand that you have base angles and a vertex angle, and that at least two sides are congruent, you could work through the proofs that they're giving you. Okay, here's another example, and this is an example that you should write down in your notes. Find the measure of a missing angle. If DE is congruent to CD and BC is congruent to AC, measure of angle CDE, so CDE is up here, is 120. What is the measure of angle BAC? Okay, so we have an isosceles triangle over here. We have an isosceles triangle over here. And we know that this angle is 120 degrees. Now, since CD and ED are congruent, we know that our base angles are down here DCE and this angle over here by E. So, how do we solve this? Well, we take 180 degrees in our whole triangle and subtract away the vertex angle. So subtract away 120. And that leaves us with 60 degrees. So 60 degrees then divided by 2, because we have to split it between the two base angles, is going to give us 30 degrees here and here. And if angle C, or angle BA, or sure, I can talk. We're looking for BAC. So since we have vertical angles here, this angle up here is 30 degrees. And this is also our vertex angle. So now we take 180 minus 30, and that leaves us 150. 150 divided by, where'd my cursor go? There we go. 150 divided by 2 gives us these two base angles, which is 75. So the answer should be D. Let's see if they go through the work. We know the base angles are congruent and that they have to add up to 180. So 2x plus 120 equals 180. Subtract 120, divide by 2. We know that that first angle that we talked about was 30 degrees. And based on the idea that they're vertical angles, we know that BCA is 30 degrees. BCA, based on the triangle, is the vertex angle. So again, all three of those angles added up should equal 130 or 180. So we have the base angles plus the vertex angles, 180. Subtract, we get that 2y, or the two base angles, is 150. Divide by 2, and we get 75. I think this slide makes it look a whole lot harder than what it is, just because they write out so much for each step. So you need to try this problem in your notes, draw the picture. If you don't want to write out all these words, at least make the marks. So mark that AB is congruent to BC, and that tells you that B is your vertex angle, and this angle up here, BAC, and BCA are your base angles, so they will be congruent. Okay, the ABC is 80 degrees. They want to know what's the measure of ADC way out here. So probably some adding and subtracting from 180, and I'm guessing some dividing by 2. The next theorem just says that if two angles of a triangle are congruent, then the sides opposite of them are congruent. This is just the reverse of the first one that we said. The first one we said if we know that these two sides are congruent, then we know that these two angles are congruent. This is just the opposite. If we know these angles are congruent, then we know these sides are congruent. Again, here is an example that you could write in your notes. Name two congruent angles. They even have them marked here. We cannot just call it angle L and angle M. There's a lot of lines coming in at both pieces. So we could say that PLM is congruent to PML. So MLN is opposite of MN, and angle MNL is opposite of ML. So angle MLN is congruent to angle MNL. So they're using these two base triangles here, the two angles that weren't marked as congruent. I would have just named the two that are in the picture. But they're also correct that this angle down here, MLN, is congruent to angle MNL based on these two sides being congruent. Okay, name two congruent segments. Well, based on how they just answered the last question, I already have these two marked, so I'm not going to rename those. But I have this angle and this angle marked congruent. So the side opposite this angle here, at PLM, is PM. The side opposite of this angle at PML is PL. So we'll say that PL is congruent to PM. Yep. All right, another drawing. So which statement correctly names two congruent angles? So look through your choices. I'm guessing that they aren't going to point out these two that are already marked. They're going to ask you to use what you've learned about congruent sides. So the drawing and your answer in your notes, please. Continuing on with these problems, now we have 3B, which statement correctly names two congruent segments. Again, I'm not thinking they're going to go with these two that are marked, so read through your choices carefully. Okay, continuing on, now dealing with some equilateral triangles. A triangle is equilateral if and only if it's equiangular. Okay, so all that just simply means that all three angles have to be equal, all three sides have to be equal as well. So in this case, a triangle can only have 180 degrees, which means every angle has to be 60 degrees. There's no other combination that works for an equilateral triangle. Okay, so they're telling us that EFG is an equilateral triangle. EH bisects angle FEG. So knowing that that bisects these, if this whole angle was 60, that means this piece and this other piece here should each be 30. EJ bisects angle HEG. Find the measure of angle HEJ and measure of angle EJH. Okay, so again, we said that this was 60 and that EH bisects angle FEG. So that made this 30, FEH is 30. That also means that HEG is 30. And since EJ bisects that, half of 30 is 15. So angle HEJ, this little angle right here, is 15 degrees. Now they want us to find the measure of angle EJH. Just reading through real quick. Okay, this forms a 90-degree angle here. It's perpendicular with the side. So that's going to be 90. So 180 minus 90 is 90. 90 minus 15 leaves us with 75 degrees for angle EJH. Let's see if that's what they do. Okay, we can't officially say it was perpendicular, even though I did. So they did the exterior angle theorem and still got 75 degrees. And then again, continuing with this example, we still have an equilateral triangle. EH bisects angle FEG. EJ bisects angle HEG. Find EJG. Okay, so again, 180 degrees in a triangle. Equilateral triangle means this angle down by G is 60, so that leaves us with 120. This is still 15 degrees up here, so 120 minus 15 leaves us with 105 for angle J. And they just use the straight line. Again, I love geometry because there's more than one way to do each answer. So if we found that this angle here, HJE, was 75, 180 minus 75 leaves you with 105. Here's a problem for you to do in your notebook. So please draw the picture and select the correct answer. Continuing with the same drawing, here's question B. They want you to find angle ADB, which is next to this 3x question. Okay, that's the end of the lesson on isosceles triangles, and that's the last lesson in the chapter, so we will be preparing and reviewing for a test by the end of this week. Have a great day.